Today's topic is data cleansing in the age of agentic AI. Before talking about data cleansing, I would like to say that I've already covered another video on are you ready to adapt AI in your business or in your organization, which we can consider as a step one. If I would recommend you to please watch that video in case if you're new to AI so that you understand whether you are actually ready to adapt AI. And this is step two. And the step two, what are the data cleansing techniques, methodologies currently which is there, which is completely different from what we used to see, what we used to do earlier. We'll go through that in detail. And after this, in step three, we can go to the business logics and mapping AI to your value chain system and further across other businesses, or other business categories. And start with the presentation. So here is the slide, comprehensive guide to data cleansing in the age of agentic AI, which is completely different from what we used to see till 2024, we can say. Okay, let's go to the next slide. So we can say the data cleansing in past 25 years, if we can categorize it as to three different era: legacy era, generative era, and agentic era. In legacy era, it's basically we used to have a structured, clean data, normalized, basically, the SQL database where rows and columns were put and the schema was put properly. Like say, for example, in data, it is defined as MMDDYY, or email has the particular characters like at the rate dot, and Excel was mainly used for this. So this was the legacy era. And of course, like in after 2012 and 2015, we started using the unstructured databases also. But the data cleaning was meant for structured, normalized, rows and columns and valid schema data. So when it came to generative era, which is like say we can say around 2023-24, the dominant technology was LLMs and RAG, retrieval augmented generation, where the data which is stored has to be accurate, piece of data, it has to be put, which is deep, non-duplicate data, where when for example, very simple example is if there is a chat bot and if you ask any question, it takes the right information based on the query and gives back automatically. Imagine if there is a contradiction, or like say if the information which is given has little bit of contradiction, there is a chances that it can pick up wrong data and goes and informs to the user. So the cleansing tool used was Python scripts, LangChain. Primary risk was AI lies. Basically, the AI so confidently it used to give all information, saying that I've read all this, and very authoritatively it used to lie. So this is the primary risk, or I mean, even today this is there. This is the primary risk of generative era. In agentic era, which is 2025 onwards, is you have autonomous agents and you have vector databases where things are becoming more complex in storing the data as well in vector databases, where definition of clean data means you have a grounded data, you have a conflict-free data, and temporally accurate knowledge graphs. What exactly it means is you have to have one data which is grounded data, which is said that this is a Bible or this is the final information where you can go and use for, which can be used for any of your actions. Because when it comes to agentic era, or like say agents, they actually go and perform actions, instead of just replying and all that. You can take action based on this. Those are the grounded information which is put, and it has to be conflict free. You can't have any contradictory information when you have that kind of data. And temporary accurate knowledge graph is where if the data pieces you have between the years, like say between 2000 to 2001 you have some valid data, and 2002 to 2003 you have some valid data. So when you're asking for a data of 2001 or 2002, it used to go and retrieve the data based on that data which is tagged to it. So this is the huge change which has happened over the years. And the primary risk here is if the data cleansing is not done, if data is not correct, AI can take dangerous actions. It means AI can actually make huge losses to the organization if data is not taken care of, the cleansing is not taken care of. Let's go to the next slide. Okay, so here we can see the huge difference, pictorially, the what we can see, from where we used to look at the clean data and what is the current way the data has been stored. For example, if you see, if you Q2, Q3, and Q4, these are some sales figures, for examples, which are put in rows and columns. Okay, some data, which is like very well structured rows and columns. But if you see currently what is how the data is stored is actually like this mind map or GPS coordinates or neural networks. This is actually a data, how it is stored currently in the vector databases. So we can see pictorially what is the huge change that has happened here. Let's go to the next slide. We see what is the new economic axiom here. So earlier we always aware of the data what we used to give in, which used to get out, like say garbage in, garbage out. This was the legacy reality. But when it comes to the agentic, it is noise in, hallucination out. So it's basically what actually happens is bad data causes confident lies. This is very important. It gives you very confidently, it gives you the lies, which people may, which has affected many businesses due to this kind of hallucination from the AI output. So, what is the inference? So, it's from Gartner report. It is around more than 100 crore in rupees. It's an average enterprise losses due to the poor data quality. These kind of noises or these kind of wrong information can lead to huge losses like this. So one of the example is Air Canada case where the return policies were not, which had some contradiction. Like say they had multiple return policies with little contradictions. So when the chatbot was speaking to the users, it always gave a wrong refund information to them. And so the courts ruled that companies are legally responsible for their AI hallucination. So this is what happened with Air Canada case. So let's understand mechanism of data storage. See, when we have to do a system, we have to collect all the data, past data, so that we understand, what and all has happened, what are the contracts have been done, how, and maybe the CRM data, what are all the discussions have been done to get this contract, and what are the values, what are the invoices raised. All this data has to be put into a system to get a value out of this. Like say, if you look at the library analogy, where all the data, what I was talking, like say contract data or invoice data, whatever the policy data, all this data, when you're putting into AI system, it has to be put in the chunks. AI can't read the whole book together and do an analysis. It understands, it understands small segments. Over the algorithm, it thinks and it gives you output what is required. So when we are looking at chunking, the failure mode happens here is when all the information there is cut without understanding the meaning. They are cut just based on looking at the spaces in between, looking at the comma or punctuation marks. Then the problem happens is it loses the context between the first line and the second line. So one of the typical example can happen here is the context loss. Like say if you the policy data, if you put all the policy data together and it doesn't understand the exception because it's been cut irregularly or because this is shredded without any technique. So let's go to the next slide to see what is the solution for this kind. The solution is semantic chunking. What exactly semantic chunking is? When you're cutting, like say, imagine if there is a statement, the CEO decided based on, looking at the quality of the products received by this vendor, fire the vendor. Okay, imagine that is the state. So in the fragmented processing, like in the earlier slide as explained, in the fragmented processing, the CEO decided to cut here and then fire the vendor. What exactly happening is there is a thought which AI is capturing, CEO decided to, and fire the vendor is action. So it took the action, isolated action, it took the thought, but it unable to connect these two. So what exactly semantic chunking is, what exactly it does is there is a semantic link which is created between the CEO decided to and fire the vendor. So once the CEO decided to come, it also has a link that, okay, fire the vendor, the action is also there associated with this. That kind of semantic link is created, okay, so that the context and the intent is preserved. So how it is done is use a small AI model to act as an editor that reads first and draws box around logical sections. So let's go to the next slide. So this is how exactly it is a core technology, we can say, the GPS of meaning. So basically, this is a very good diagram which gives clear picture on how exactly they are stored in the vector database. For example, if you see the apple here in the green left side and in the violet, apple and the complete right hand side, both are apple, but the distance between them, like if you see it on a GPS map, the distance between them is very far. It's a multi-dimensional GPS mapping where the meaning of this apple is completely different between this apple. That's why the distance between them is very far. However, this apple is associated with grape, orange, banana, and stuff. And also, there is a small link of phone here. So that you know that apple means it is also a phone. And here, the same thing. This apple is more to a computer, this company, and all that. And if you look at dog is somewhere else and cat, but somehow dog and cat are little bit linked because both are animals kind of stuff. This is kind of representation how data is stored currently in agentic era. One important thing which we need to understand is the permanent risk. Putting any dirty data into this map, it has to be very careful because it's very difficult to remove that from this, because it means burning into the map forever. Like any data putting into this, it's fairly complex. It's very difficult to go and delete the thread and stuff like that. So let's go to the next slide, which is the hidden risk, the echo chamber problem, called as zombie doc. So what exactly happens is, like, if any organization, you have multiple policies, like say you both the policy name is contains a name final. When we have uploaded both the files, when the AI is reading both the files, it can only detect if the file name is same and the file size is same, then it removes the duplicates. Otherwise, it keeps both the files. And whenever there's any user is talking, the employee is asking some information about the policy, there is a chances, 50% chances it gives the wrong data, the wrong information back because of the different two different documents which is available. The solution is SEMDDUTE. It goes and checks the date, the context, on all the policies and everything. It purges all the irrelevant or obsolete content and create one single document, which is, we can call it as a single source of truth. It goes and creates a single source of truth, which not only helps in giving the right information when the user is asked, it also helps in reducing the storage costs because it is purging a lot of information. So let's go to the next slide, which is compliance, privacy, firewall. See, in agentic AI, the problem is editing of any data which is fed into AI network or fed into neural network memory is very hard, very difficult. So before feeding any important or critical data of user, you have to take some preventive actions before feeding any critical information into the AI system. The reason is because of the law right to be forgotten, like regulations like GDPR or DPDP. There is a mandate that see, you can't leak the critical data of the user, because once it gets into the AI, you have no AI can go and exhibit that data to anybody. Can show it to anybody. You have to be very careful of putting that kind of data into the system. So how to prevent is, the protocol is redact first. The way to do is you create a redact tags, or like say for example, if you have a username or a password or a credit card number, username is put into a pseudo name or something, and then the password pseudo password, or mask it and put those information into the AI. Run We can send those information into the AI along with a user ID tag, so that when we have to retrieve it back, you can retrieve it based on the user ID tag which is mapped to it. This is how it can be taken care of. Let's go to the next slide, which is risk evaluation. The risk factor is very high in agentic AI. See, in earlier, like say if we look at to chatbot and all, if it is a bad information, the AI used to give only the wrong information. It only used to give some information, wrong, which used to affect the reputation of the company. When it comes to agentic AI in 2025, it is performing actions. It is basically going and saying, okay, dispatch this good. It is giving a delivery note, and it is in getting the inventory into the system when the inventory is getting over, and it is going and giving refunds to the people if they are asking for, based on whatever the policy has been set. So this is going to be operational disaster if the data is wrong. Like, say, what are the solutions for this? Is keep some safety break. The safety break is, like, say, you can't pay, like agent. You have to keep some human intervention if the amount is going beyond certain limit, or if the processing is taking too much time, then it has to stop over there and go to the human to answer this, take care of such things. Simulation testing is where you have to give all kind of wrong information. It is basically the critical testing of any software, what we are doing. But here in this case, all kind of edge cases, all kind of wrong information, all kind of wrong inputs, testing has to be done thoroughly into AI system to ensure that it passes all kind of tests before actually making, at least the part by part, whatever thing systems which are completely ready, like, say, dispatch is completely working fine. Only dispatch can be enabled completely for agentic. Let's go to the next slide. The execution strategy is, on an average, we can look at a 10-month roadmap. It involves 3 to 4 important part, like, the audit part, the pivot part, the governance part. The audit part is where we have to identify these are the critical documents which has a lot of value about the business. It has all the insights about the business, like, say, policy, or earlier invoices, all the transactions, all this information where all the business intelligence is there. All this information, but has to be taken as the priority. First that has to be audited and segregated. That is the audit. It actually takes, depending on the company, it takes 1 to 3 months, approximately. Next comes pivot. In the pivot, it is switch from legacy ETL to unstructured ETL. ETL is extract, transform, and load. So this is where, you're putting into data. Before putting into database, this is what has to be done. The way to do is, like, so we'll have a lot of unstructured data, like, say, PDFs which has graphs, which has, a lot of columns, and lot of, in some places, some handwritten things. All that will be there. All this has to be, read into meaningful segments. It has to be created, the chunks, as we were talking, with the semantic link and all that. And it has to be read like a human is reading the book, not like a computer. It's running through the OCR or a ICR. It's just character recognition. It is more to do with human is reading and understanding the meaning of each graph or the tables, and associate with the right information, where it has to be attached to, and then create a vector pipeline. The output of pivot is create a vector pipeline which transforms all business knowledge on a conveyor belt to the AI system. So the phase 3, which is governance, it basically pertains to implementation of privacy firewalls and also semantic drift. Privacy firewalls, as discussed earlier, is ensuring the privacy of the user information, sensitive information is taken care of. And semantic drift is data over different timelines is kept in order to maintain the accuracy. The output here is a compliance engine that ensures that AI usage is accurate and secure. If we discuss about the last 2 points, which is don't boil the ocean and the budget shift. Don't boil the ocean means basically give importance to only the documents which are business critical documents, like scan documents, or you have business proposal documents where you have vendor contract documents or policy documents, and any Excel sheets which are, like, contains large amount of business data. Those are important ones. Don't give importance to data where, the redundant data is there, multiple versions of data is available, or which contains some trivial content which is not something related to the business. The last point, budget shift, is where I think it has to be phased out really well, by looking at, moving away from the storage data money, the money which you're spending on storage data, into the paying for processing into the vector databases. which is possible once we understand what are the critical data which we already looked at, and slowly we start, trying to shift some budget from here to here. It can be done in a phased manner. The final recommendation is choose your future. Semantic hygiene is not just cleaner; it is the absolute prerequisite for the AI success. I hope it has given you some clarity on the data cleanliness required for the agentic era. Thank you.